Yes, hi, and thank you for joining. Yes, I will tell a bit about redundant streaming over public internet. And I'm founder and senior technical account manager at Intinor. It means I work with customer and support. So let's go into this. I'm going to talk today about a little bit about Intinor and what we have done, just so you get an understanding. And then I will talk about SRT, and I will talk about redundant SRT based on open standards. And I will give you a few key takeaways, things to remember from this. So, Intinor, we have been doing live video over internet since 2003. Private-owned company in northern Sweden. We do all the in-house R&D and production and development in Sweden. We have shipped now more than 2,000 units, encoders, routers, decoders for live video over internet. And the core of what we have been doing is a transport protocol with bonding and redundancy. So we understood that this is important. When people start using internet, there is a lot of problem with internet, and then redundancy is one key thing to use. And our protocol can do bonding between Ethernet and 4G, 5G, even satellite. We have error correction, we can do ultra low latency, and we can do adaptive bitrate and things to make it robust and safe over internet. And we do encoders for sending live streams, and we do routers and other products for receiving the streams in the control room, for example. We support other protocols as well. We support SRT, RIST, RTMP, and many other protocols. So we try to make it possible to use for many different applications. And why would anyone want to use internet for live streaming? Of course, it's very cost efficient compared to fiber and satellite. It's also flexible, so it's easy and fast to deploy. You can set up a streaming from internet without so much planning and high cost. And what you may want to do is you want to share your content with partners live over internet. You may want to send from a studio or location somewhere into a control room. You want to do a remote production to save cost, because you don't have to have so many people on site. And this is usually for sport and events. You may use internet also for distribution. You want to distribute some local TV channel, regional minority channels to cable TV head end. You can also use internet as redundancy for satellite and fiber. And as I told you in the beginning, we have developed our own protocol, but the problem with that is that it's only supported by us, so you can send between our products. But if you want to start sharing your content with others, you need to use open protocols. And there are two good open protocols now. One is SRT, and another one is RIST. And I'm going to talk about SRT here, because it's the most commonly used open protocol for sharing video over public internet. So SRT means that there is interoperability. You can send and receive from others. And we are a member of the SRT Alliance, so we work very close and follow and try interoperability with other vendors. SRT, secure, reliable transport. And it's a royalty-free open source protocol for live streaming. It has encryption, it has error correction. It was developed by Haivision, and it's supported now by many, many vendors. There are many partners in the SRT alliance, which means, or should mean, that there is interoperability between those. But there is also a common misunderstanding that any SRT encoder can send to any SRT decoder. But it's not really that easy, because SRT is a protocol to send live data. It doesn't specify what is inside SRT. It's mostly used for sending MPEG transport streams, but it can actually be used for sending other things, other protocols over internet. MPEG-TS, that's a standard that an encoder and maxer can comply with. But even if you follow the MPEG-TS standard, not all the decoders can understand this, because there is also DVB, and DVB is more strict about, for example, the PCR accuracy. So not all decoders can receive an MPEG-TS, which is a little bit jitter and other issues. So, and it's also not true that all decoders support all the codecs that can be inside the SRT streams. So, for example, you want to have a decoder that supports at least MPEG-4 and H.265, and you can want to support 420 and 422, and you want to support 8-bit and 10-bit maybe. 4K, multi-track audio, Dolby. So it's not that all other decoders support this, but our encoders and our decoders are DVB compliant and support multi-codecs. So we can be very good at sending to others and receiving from others. So this is important to think about. Your encoder should be DVB compliant, and your decoder should accept multiple formats, so that you don't always know what your partners want to send to you, and then you shouldn't have a decoder that only supports H.264, for example, because then you may get an HEVC stream. So there are also limitations with SRT, and one limitation or two limitations are there is no network bonding, there is no redundancy. So there is only one path over the internet when using SRT. There is something called path redundancy in SRT, but it's only supported by very few vendors. So it's not really something that makes it interoperability. Error correction is good. It can handle some packet loss on the streams, but we have a lot of experience in this, and there are two other issues that come up once or sometimes. And one is congestion. You want to send 10 megabit, but the internet doesn't allow you to do all that bit rate. So especially when you start your transmission, it may work fine, but after some time, you will have problem with congestion. And the other one is interruption. Anytime there could be an interruption on the internet. And if you're sending a single path from an encoder over internet to a decoder, you basically have 3 points of failure. You can have a bad internet on the sender side, you can have bad internet on the receiver side, and you can have a bad internet somewhere between. So now we come to redundant SRT, and then we are using several building blocks, and this concept was developed by Eurovision Services. And the reason why they came up with this was that they, of course, have a lot of content they want to share with takers all around the world. And more and more takers are taking SRT streams. And the problem then becomes that some people have problem with the internet, and then the SRT streams have issue. So what they did was they came up with a way to put RTP on top of SRT, and then send redundant stream and use another open protocol, SMPTE 2025-7, to do the seamless redundancy between the two streams, two or more streams. RTP, real-time transport protocol. That's quite an old way of sending live streams. So it runs over UDP. It doesn't provide any error correction, but it gives a header with a sequence number and also timestamps. So the decoder can know which packet this is and when was it sent from the encoder. SMPTE 2025-7, that's a little bit newer standard, but it's a way to get 2 or more RTP streams in, and then you can do redundancy between the two streams. And this has been used for multicast RTP or unicast RTP, but now we can also use it for RTP over SRT. So by combining those building blocks, it's possible not only to get redundancy between two SRT streams, but you can also get redundancy between fiber and an SRT stream, and you can get redundancy between satellite and an SRT stream. And the path redundancy I was mentioning before, it only covers 2 SRT streams, but this is more generic. It can combine different kind of transport and do seamless redundancy. How does it work? If we have an encoder, like on the left side, an SRT device that can take either an MPEG-TS input or an SDI input, and it has 2 internet providers, and then it can send 2 RTP over SRT streams. And on the receiving side, you can also have 2 internet providers, and you can receive those RTP streams over 2 different providers. And by doing this, any of the internet providers, 1, 2, A, B, can have issues, but you will not have any problem with your stream. So even if the encoder doesn't have 2 internet providers, you can still have 2 internet providers on the receiving side, and you can achieve a little bit redundancy, or the other way around. But the best is, of course, if you have multiple internet connections on the sender side as well as on the receiver side. When you're sending redundant SRT, it's important that you max and deliver a DVB compliant stream, because otherwise everyone cannot receive it. You want to send 2 or more identical streams. You want to support both caller and listener, because some of your takers may want to be a listener, some may want to be a caller. You want to be able to configure different settings for different takers. If you want to receive an SRT, it's important to have a decoder that can support multiple formats. It's also important to have some statistics for SRT, so you can troubleshoot if you have problems receiving the stream. Eurovision Services has a list of supported decoders, and that will help you to get an idea of which decoder you can use to receive redundant SRT streams. It's also important to have a good management system so that you can get an overview and see where you have a problem and monitor and make it easy to troubleshoot. And also, of course, to have a good support from your vendor and your partner. It could also be that you don't know exactly what you need in the future, so it can be good to buy a product that is flexible and support both inputs and outputs and can be configured for your next project in another way. My key takeaways: sending video over internet can be as robust or even more robust than just using a single fiber or a single satellite. It's a lot more cost efficient. but make sure to use network redundancy. Don't just send over one internet connection. You can also use bonding, but redundant SRT is the best choice for interoperability if you want to be able to send to other other vendors, and if you want to receive from other. So redundant SRT is a good protocol. And yeah, my time is up, but my presentation is finished.